Hi everyone. Today we are going to discuss about the chapter equivalent UDL. So what do you mean by equivalent UDL? Since it is a rolling loads, we have gone under several conditions such as single point load, 2-point loads, a series of point loads, even the UDL of shorter than span and longer than span. There are several categories of loading in rolling loads. So just convert all these loads into a single UDL, so which will be very much useful in minimizing the problems in calculation. So equivalent UDL is a single UDL which is a converted part of all the type of categories of loads. Let me go to the problem. So for before that I am designating everything. So load of equivalent which is related to shear force and load of equivalent which is related to bending moment. I am just designating these two elements. So in order to know which is the equivalent load, equivalent load corresponding to the shear force and equivalent load corresponding to the bending moment, right? So for a simply supported beam, for any span, maybe it's L, so if it is the intensity of W, so the total load will be WL and it will be acting at a point of L by 2. And the responses will be, the reactions will be WL by 2 and WL by 2. So thereby this is A and this is B. So this will be equal to the load, equivalent load of shear force at A, and this will be W equivalent load of shear force with respect to B. So these are the things. So by directly we can get it out, and we know that for a simply supported beam of UDL throughout, the bending moment formula will be W L square by 8. So here it is W equivalent with respect to moment into L square divided by 8. You just keep these two in mind, since these are the basic elements by which we are going to calculate tau. So this is the equivalent loads. Now how we can determine this equivalent load? We are going to do that step by step process. So shall we take a single point load for this class? So I am taking a W, so which is of length L. I know the intensities RA/RB response ILDs, so this will be L and this is 1, and we need to superimpose the load here which is W. This is positive shear force, F max positive, absolute maximum shear force, and negative shear force, this one is 1. I am superimposing here the load and for the same distance, so negative absolute maximum shear force. This is the negative maximum shear force, and we know that the maximum bending moment will occur, the absolute maximum bending moment will occur at the distance L by 2. So that is the profile for bending moment. So this formula is, this is A and this is B, this is a positive profile. So the intensity is X into L minus X by L. So which is X is L by 2 into L minus L by 2 divided by L. So which is L by 2 into L by 2 divided by L. So which is L by 4. Obviously this is L by 4, and I need to superimpose the load here which is W. So now I am calculating the moment. So what is the moment here? Moment is load into ordinate. So what is the load? Load is W into ordinate is L by 4. So the formula is WL by 4. So this is the acquired moment and this moment is the equivalent moment. Now substitute the moment equal to equivalent moment. So even the reverse, equivalent moment is equal to moment, whatever it may be. I am just making it for the calculation purpose. So WEM into L square divided by 8 is equal to WL by 4. So you just keep only WEM aside. So that's WL into 8 divided by 4L square. So this will get cancelled and this will get cancelled. So the equivalent UDL load in case of moment for this condition is 2W by L. So that is the formula. And we'll calculate, this is for moment. This is for moment. Next we will calculate for shear force. Next for shear force, F. So for F, maybe you take positive, both has the same value. F positive is F negative. So what is that? It is load into ordinate. So I am taking positive alone. So load is W into ordinate is 1. So which is W. So we need to, so this is what, this is the shear force of A, or positive shear force, and this one is the equivalent shear force. Now equate the equivalent shear force to the maximum, absolute maximum shear force. So the equivalent shear force is WEF into L by 2, which is equal to W. So what will be the WEF? So which is 2W by L, which will be same. So but no matter, here it will change, not for all the conditions it will be same, that for the load, equivalent load of a bending moment is always equal to the equivalent load of the shear force. There is no such conditions. For this condition both seems to be same, and this load is WEF, this load. So this is also WEF per meter, and this is WEF into L. So this is also WEF into L by 2. So this is how we are calculating the equivalent UDL in case of shear force and bending moment for a single point load. Thank you.